about the solution, like what we did. So if I have a slave node, we generated a node table. So each node knows which is the nearest neighbor to send the message so that it can forward the message to the master efficiently. And here we have the position for each node. Like for example, the master node is in the position in 1 2 3 1 2 3 in the 3 3 position. And if I select any node, like for example 4, so it has the position like 1 2 3 4 0 4 0 position. So it knows where is the master node. So to send the message, either it will send the message to the nearest neighbor 4 to 9 or 4 to 3, so that it can forward the message to the master node. If the message comes to 9, it always forward the message to the nearest neighbor to 8 or 9 to 14. So if I have the message to 14, the message will be forwarded to 13 immediately, because it is the nearest neighbor and the master node. So that's how the traverse will work. Now I'm going to run the code. So let's see how it goes. So I'm set the send interval like 10 seconds, and each 10 second all the slave nodes will send a message with random temperature, and each slave node will forward each other's message. So let me wait for the next sequence. In 20th second it will send the next message. uh, yeah, so it's sent. So here I going to pause and let me show you the log. So from the sequence 1, here we can see I have received all the message from all the slave nodes, so there is no missing. And the maximum temperature is recorded as 95. Yeah, so as we can see, we got all the message from the slave nodes for 25 nodes. Let me show you the same code for 49 nodes. Then we'll see some weird things like the missing of frames. To run our code for 49 nodes, I had to change the number of nodes to 49, and the table size is 7 into 7. So let me reload our uh, simulation for 49 nodes, the speed, so that I can get the message faster. So in 10 seconds it will send the first message. As you can see, all the messages traverse from each node to the master node, and in 20th second it will send the next message. Yeah, so now I going to pause here, and let me look in the log output as a summary. So as you can see, for the sequence 1, we got the maximum temperature 95, and the number of received is 39, and missing is 9. So as I can see, we have some missing data, because there is no I mean, there are some cases maybe all the message is not forwarded to the master node. uh, yeah, so that's how it works. So now I am going to discuss about the code, how we implemented it. So for each node, let me find it. Yeah, so first I just initialize the node configuration. We have generated the node table. For each node it will generate the node table and also calculate its nearest neighbor to the master. Okay, so here it's pretty simple. Each node will generate a sequence number and just get a random temperature, and it will send to the nearest neighbor, so either up or down or left or right. So it will send in to only one nearest neighbor. So whenever any node receives any data, so it will forward the data to the nearest neighbor. The address of The address of the nearest neighbor is calculated because we found a nice pattern. If we know the node ID, then we can generate the address uh, simply like this. uh, yeah, so simply like this we can generate the address, so there is no problem with the address, so we can forward the message, I believe. And in the master node, when it gets the data, let me show you the what is done in master node. Yeah, so here, so if I have the data for the next sequence, so I show the summary what we have received from the previous sequence, and then we reset the variable and we prepare for the next sequence. So that's pretty simple. So now I'm going to show you the evaluation part. So for evaluation, we just generated logs for 9 nodes, 25 nodes, and 49 nodes. So I'm not going to discuss how we just parsed the log from different log outputs. Just I will show you the graph. Yeah, because from the graph it's clearly visible the uh, clear scenario. Yeah. So this is my first analysis graph. So this is our latency test. As we can see, um, from if we have like 9 nodes, then the average latency is like 200 millisecond. And if we have 25 nodes, then the average latency is 600 milliseconds to reach all the data. If I have 49 nodes, it's the average latency is 1000 millisecond. That's how we show. And we have another graph for reliability test. So from this graph, we can be sure that for 9 nodes, we don't have any missing data. So all the time, the master node will get all the data from the slaves. And we also seen for 25 nodes, most of the time we get all the data, but sometimes we miss one or two data from slaves. And 49 nodes, we never got 100% data. So the average success rate for 49 nodes is 82%. So that's how our evaluation. Yeah, so I'm gonna end this video right now. Thank you for listening to us.